Next ANFIS application is inverse kinematics problems. Here we use ANFIS to model the inverse kinematics of the two-joint planar robot arm as shown in this figure. This problem involves learning to map from an endpoint Cartesian position x, y to joint angles theta 1, theta 2, and it requires that the end effector, that is the hand, be able to follow the reference signal without being given the joint angles. The forward kinematics equations from theta 1, theta 2 to x, y are straightforward. That is, x is equal to L1 cos theta 1 plus L2 cos of theta 1 plus theta 2, and y is equal to L1 sin theta 1 plus L2 sin theta 1 plus theta 2, where L1 and L2 are arm lengths and theta 1 and theta 2 are their respective angles. The forward kinematics equations from theta 1, theta 2 to x, y are straightforward. That is, x is equal to L1 cos theta 1 plus L2 cos theta 1 plus theta 2, and y is equal to L1 sin theta 1 plus L2 sin of theta 1 plus theta 2, where L1 and L2 are arm lengths and theta 1 and theta 2 are their respective angles. The inverse mappings from xy to theta 1, theta 2 are not as clear. It is possible to find the inverse mappings algebraically, but the solutions are not generally available for a multiple joint robot arm in 3D space. Instead of solving the equations directly, we use two ANFIS systems to learning these inverse mappings. When root of x square plus y square is greater than L1 plus L2 or less than mod of L1 minus L2, there is no corresponding theta 1, theta 2. This is called the unreachable workspace. The form of training data pairs is x, y, theta 1 and x, y, theta 2 respectively to train two ANFIS systems. 3 membership functions are used for each input. There are 9 rules and 45 parameters for each ANFIS. Next ANFIS application is automobile MPG prediction. It describes the use of ANFIS for nonlinear regression. Address the issue of input selection for finding important input variables and reducing training data dimensions. Automobile MPG. MPG stands for miles per gallon. Miles per gallon. Miles per gallon. Automobile MPG prediction is used as a case study. An automobile's fuel consumption in terms of MPG is predicted by ANFIS based on several given characteristics such as number of cylinders, weight, model years, and so on. 6 input attributes includes profile information about the automobiles, number of cylinders, that is multi-value discrete, displacement continuous, horsepower continuous, weights continuous, acceleration continuous, modal year multi-valued discrete. The attribute to be predicted in terms of the preceding that is these 6 input attributes is the fuel consumption in MPG. The attribute to be predicted in terms of the 6 input attributes is the fuel consumption in MPG. To apply AMPHIS to MPG prediction, we need to take care of 2 problems first. First one is data scarcity and the second one is input space partitioning. So first one, data scarcity. For a single input data fitting problem of medium complexity, we need 10 data points to come up with a good model. For 2 input, 10 power 2, that is 100 data points. For a 6 input, 10 power 6 data points. This is prohibitively large for any common modeling problem. Data instances may be very less. Next is input space partitioning. Grid partitioning is the most frequently used input partitioning method. For a problem with 6 inputs, grid partitioning leads to at least 2 power 6 is equal to 64 rows, which results in 6 plus 1 into 64, which is equal to 448 linear parameters. If we are using first order Sugano-Fuzzy model. Before training a fuzzy